Welcome back. If you are watching this on YouTube, you will see no change. If you are watching this on LinkedIn, welcome back. You had to click a link. Maybe that's why they call it LinkedIn. I don't know. But I am joined here now with my friend Rishi. I think we're friends. We've talked a few times. Rishi is from ProjectDiscovery, and they run several things, one of them being Nuclei. The thing I'm most familiar with is Nuclei. Nuclei is the hotness when it comes to proving that vulnerabilities are real, I think. Like, that's usually how I describe it. And this is force multiplied, community-powered vuln detection. And so, Rishi, how would you describe Nuclei, since you're in it every day?
Yes, I can start with the story. Like, how did we start?
Yeah.
So all the co-founders were working as security engineers in different companies. And one of the key challenges we used to face was every time new CV used to drop, it would basically create such a noise within our company. Like every instance was pretty much vulnerable, but turns out most of them are not actually exploitable. They are very rarely exploitable. So we wanted to make sure how can we figure out a way to describe vulnerability as a way to validate them step by step, what a human would do. Like, okay, I'll go to this specific endpoint, I'll send this payload, I'll watch the payload response, and then I'll confirm that it's actually exploitable. And that was one of the key insights we got, that we need some framework around validating vulnerabilities, and we created this framework just internally for us. And quickly, we open sourced it and realized that this is actually a bigger problem than just us. Every time new CV drops in or new attack drops in, the noise to actual validation becomes such a big challenge. And we open sourced it 5 years back. And luckily, we got such a massive contribution from community. Every time new CV drops or every time a new attack drops, community helps them to craft these templates.
Right.
And these templates are YAML-based, very simple to write, very simple to describe.
Right.
You can easily collaborate with multiple teams. Everyone can know how does it work, each step. That's how Nuclei work.
So Nuclei, the guts of Nuclei are written in Go.
Yeah.
The Go language. But like you say, the templates themselves, like the attacks. We don't like saying attacks, right? But the attacks are written in YAML, which is yet another markup language. Not a criticism. That's just what YAML stands for. And so I think that was the thing. And you tell me, right? Like, when you say that you had like this, when you open sourced it, you had a whole bunch of community contributions. You don't mean money, you mean fingers on keyboards, right? Do you think that it's because of the... I don't want to put words in your mouth. I think YAML is a big reason for it. Why do you think you got such quick uptake and to the volume you did? Because it is only 5 years old.
Yeah, I do think simplicity is one of the key reasons. Like, how can you easily describe a vulnerability in a template is actually difficult. Like, before Nuclei, if we had to go through the POCs, there were like random Python POCs, Ruby POCs, all these different complex ones. And you could reverse engineer them, but writing them becomes a difficult work for you. So simplicity was one of the reasons. But I would say the problem was bigger than just the writing of the template. Everyone wanted to make sure what are the instances across their stack, or what are they working on are actually vulnerable. So everyone wanted to solve the problem together. So that kind of force became a kind of a collaboration between community. And there was a tipping point. Like, that was the time when we started seeing a lot of CV to exploitation phase dropping more and more. And luckily we were in the right timing that we had a kind of a community collaboration to do it. But I would say it was a problem for all the noise and every detection issues, as well as simplicity of writing it.
And so you said the word noise like 2 or 3 times now since we've started talking. What do you mean by that? Like, is it just like garbage proof of concept? Is it vulnerabilities that don't matter? Like, what do you mean by noise?
Yeah, I would say both. So it's like just to give you a bit of a picture on how security engineer lives through it. Every time a new CV drops in, usually when you run a scan across your infra, you will find hundreds of different instances vulnerable for them.
Right.
And the reason of that, because they are going after version detections. They will see that, oh, Apache 5.4 is running, you are vulnerable.
Right.
And you will see that, oh, we have hundreds of different services vulnerable, and we need to figure out a remediation plan, and that becomes such a chaos and noise for you. And if you go through the open source, every other CV had different flavor of script. Some of them would write in Python, some of them would write in Perl, and some of them will have weak matches. And it was like quality was not up to the mark, and we wanted to make sure that the writing is simple, the actual part of the logic is well defined. So when I'm running a particular template, I am getting a clear signal that this is actually exploitable instance. And it used to reduce noise a lot. Like before that, we used to see hundreds of different instances vulnerable, but after that, there could be like only few of them actually vulnerable to the actual CV. And that is really important for your remediation plan. Otherwise, you will create such a massive chaos within the team. And that's something we wanted to solve.
So how much so you're describing like this drop off, right? Where a vulnerability scanner might say, oh, you've got hundreds of vulnerable instances. And we're like, oh, do I? Click, turn on the Nuclei machine, run a Nuclei template, and it's like, oh, it's only these 10, right? Or something like that. Like, why is that? Are you worried about this? Are you worried about running into an implementation trap on your proof of concept where like maybe the Nuclei template is only exercising one particular vector, right? Where this may be a multi-vector, which is I don't want to say often the case, but it's sometimes the case, right? Where like you'll have a vulnerability and there's many ways to exploit it, but all the proof, like the Metasploit way might be one, the Nuclei way might be another, but there may be 7 more that we don't know about, right? Like, do you worry about this at all?
Yeah, I would say like pretty much every other vulnerability we saw, especially the most important ones, right after the first pull request like merged in, we saw maybe like 10 or 15 different follow-ups to that. There's a different angle that we missed. There's a false negative happening. There's actually a false positive happening. And luckily, because of community, you can like manage that because everyone is running in their own instances. You are getting such a global data around it. But yeah, this is like one of the things we do care about. Like, are we missing right now, or did we miss the actual instance which could be exploitable, but the Nuclei did not catch it?
Right.
But I would say the actual, like if I compare with my previous world and this world, the previous world was much more chaotic, much more noisy, and you could not actually move the needle much faster compared to this one, which feels much more calmer. So yeah, I would say in the contrast, this world is much better to live in, where you can remediate much faster to the ones that you know that are exploitable versus hundreds of them being vulnerable.
Right. And obviously, like, if there is a new patch, right, for Nginx or a new upgrade or something, yes, everyone is going to apply that eventually someday. Would you say that like some of the value of running Nuclei, right, in your environment is to be able to identify like which ones you patch first?
Yes.
Okay.
Yeah, we always been focused on remediation efficiency, like how fast you can remediate, especially on a hot CV.
Yeah.
Like if there's a hot CV and you see like, oh, all the Next.js instances that I'm running are all vulnerable, but no, you are not. Only like 4 or 5 of them are using this component that could actually be exploitable.
Okay.
And especially in that period of time, you want to accelerate on patches and remediation. And if you have multiple teams, especially in a bigger organization, you have multiple teams running a lot of these common tech, that becomes such a massive problem for you to remediate. And that's something we wanted to kind of like solve out. So remediation always been our kind of like key metric that we wanted to focus on writing these templates.
How would you So, full disclosure, I used to be the technical manager of Metasploit. We thought we were very clever in writing things in Ruby because, Ruby's easy. Boop, boop, boop. How hard is it? It turns out it's hard. I very much appreciate YAML. I think, HD would agree that, like, Nuclei is categorically better than Metasploit these days. It's more modern. Yeah. It's very web focused. It's very web focused, right? Like, what are the so I think let's go from there, right? Like, what are the kinds of targets? I can't think of a better, nicer way to say that. What are the kinds of targets that Nuclei is good at, and what are the kinds of targets that, like, Nuclei is not going to be good at? Like, can you say, or is this too embarrassing?
No, I can say, like, where do we get the pull from community?
Yeah.
So technically, Nuclei does support pretty much all the protocols, and you can write any kind of complex exploit.
Okay.
But I would say the majority of the users or community members who are writing these templates are running against external facing infrastructure. So these assets are mostly web apps, APIs, stack, and they would write the template so they can actually scan across them and find the vulnerabilities. But yeah, I would say the ratio is much higher in that, but that doesn't mean, like, Nuclei doesn't have protocols defined to write those kind of templates.
Are there areas where you would recommend people not run Nuclei? I'm trying to get you to say something bad about Nuclei.
Yeah,
you're an engineer, dude. Like, you know where all the bugs are.
Yes. Any instances that are very sensitive, like OT devices, internal devices, you need to be super. Like, we have seen there are actually tweets about people where they have run Nuclei and, like, their random printers were, like, printing random stuff.
Yes.
so that means, like,
we also learned that lesson.
So that's on those places you need to be super careful. Like, if you are in a like running a factory, or you have such a sensitive devices, like in a medical devices inventory, you don't want to, like, shoot all the templates. No. Those templates could run in a very different variations and can actually hurt your assets. So we always recommend those who are running the templates craft the ones that they should have clarity how they would be running and what are they actually getting the insights on. And majority of them we recommend on those sensitive ones do not write those active templates, like those who probe the IPs. Don't go into those phases because good amount of chances you might actually hurt the devices. So yeah.
Thank you for that. How would you characterize, like, your average, your median level, like, Nuclei contributor, Nuclei template contributor, right? Are they people who are, like, beginning career, late career, hobbyist, developers, super hackers? Like, who's contributing on the back end here?
Yeah, we do have a pretty good global distribution of users. So everyone comes from completely different country. Like, someone would write from Vietnam, Indonesia. Like, that distribution is such a good to watch. Right. I would say we rarely see developers writing the templates. Okay. Majority of the time we see like pentesters, red teamers, are those who care about probing the vulns. Bug bounty hunters are really one of the key assets for us because they usually probe for different instances, and they are the ones who are contributing, and they are also really good in terms of community contributions. We see a lot of people from AppSec, but we have seen people from students to all the way to really senior engineers contributing. But I would say majority of them are security background, not developers.
You've mentioned before that you and the other founders met essentially in a GitHub issue queue.
Yes.
Is that happening in Nuclei now, like with these, like, very senior hacker types versus students? Like, are people, like, hooking up and, like, doing mentoring? Is it happening in the queue? Is it happening off the queue? Like are you running a hacker dating site, basically? And should you? And the answer is yes to the last one.
I would say yes. We are very, like, biased towards, and we, like, all the co-founders met on GitHub, so we are very close to open source and how much value it brings. Like, you can contribute such a really technical work, you can bring the value to the community, and there's another side of the people who would actually know that this is how it works. I can also contribute, so that kind of alignment within the open source is just really, really good. And even like, in fact, good amount of our team members are from open source. Like, we have seen them actually creating pull requests, contributing to our open source, and then they joined our team. So this is a common trend we see in our team as well as across different repositories as well. Like, a lot of people collaborate right after they either create a GitHub issue or mostly pull request is one of the key reasons to get the attention of the author. If you write a really good pull request, you will immediately get the attention from author that, oh, this is such a good contribution.
So these are people who are coming in maybe after the first Nuclei template for CVE 1, 2, 3, 4, 5, right? That ships, and then you might see someone come in, say like a PR against that template, now that it's in main, right? And then that's where the collaboration happens?
Yeah. Pull request is where the most of the collaboration happens, and we also see a lot of like collaboration within the community people, like not just us. Like, whenever someone creates a really good pull request, there will be 4 or 5 different community members jumping in, giving more insights. Oh, you missed this, you missed that.
Is the so like, can you characterize the attitude then? Is it a lot of like, you're doing it wrong? But hopefully with a pull request to back it up, right? Like, I'm hoping people are not just coming into the PR and saying, like, you're doing this wrong, and then bailing, right?
Yeah. No, I won't say that. We have rarely seen, and whenever we see someone becoming toxic, we usually message them or ban them through the repository. That's like a common approach.
Okay.
We haven't seen, because this is something, a common trend across especially on Nuclei templates. It's very common trend where even if you create really good pull requests, you probably would have missed something.
Yeah.
And everybody knows that. You might have missed one angle, and whenever someone comments back, they are in that mood that you are going to track that feedback and going to improve the Nuclei template. So it's actually kind of like a very common collaboration.
So you should know coming in then that's like someone's going to be telling you, it's like, you missed a spot.
Yeah.
Okay.
Yes.
Because I do think that like kids these days, they're a lot of, especially, younger people who are technically minded, who are into this, right? Like, may not be very comfortable with like publishing open source.
Yeah.
Would you say, in your own words, that Nuclei is a good place to start doing this? Like, especially if you want to do security, like as a job, maybe you're in school, maybe you want a career change or something like that. Like, is Nuclei that place where you can kind of dip your toe in, try a little, because there's no real penalty for failure on any of this, right? Because what's the worst that happens? You get your PR doesn't land.
Yeah.
Right.
But I would say, like, we still recommend people to do a bit of quality work upfront.
Okay.
So it's required.
Well, yeah, you don't want to push the burden, right, to the 3 people, right, who do them all.
Yes. Okay. Especially with the AI, it's just easier to create slop.
Yeah.
And keep in mind, like, we all the templates that goes into the pull request, there are like 60 members that reviews them, simulates actually what's happening, and then they verify the quality, and then they merge. So it's a lot of work for them.
Right.
So if you create not a good quality, it will create a burden for them. Right. So we always, one of our guidelines within the repository is like how to go through understanding on creating a Nuclei template and how you can contribute. We actually encourage everyone, like whether you're a student or someone getting just started in security, to contribute. But there is a process that we always recommend through. Otherwise, it creates a human burden in the end. We do not really have an AI in between to help us.
So, in that vein, there are people that will show up and through the goodness of their heart or because they're learning about something, they will give you a pull request. You have a bug bounty program these days. And I know this because I've been graphing Kev listed vulnerabilities against when is the Nuclei template published and when is the Metasploit, or if, right, if and when, either in Metasploit or Nuclei, when do they show up? And I've noticed that the Nuclei line is starting to meet the Kev line. Like, you'll see them same day. Is this because of the bug bounty program?
Yeah. Yes. That was one of the key programs we started last year. And This is actually becoming a problem for us.
Okay. No, you don't say.
No, not the bug bounty program, but actually the security community, what security community is facing is actually becoming a pretty intense problem. The time to exploit used to be days a few years back. Then it started shrinking to hours. And one of the reasons why we created Nuclei templates repository was to collaborate on all the trending exploits, like how fast you can write the template and scan across your assets and fix them. And turns out the attackers are moving much faster, especially with LLMs, and that timeline is shrinking more and more. So we introduced the bug bounty program last year to kind of like figure out how we can accelerate on all the new attack vectors, especially on KV's one, how fast we can write them, and how fast we can review and merge back into the repo. So we give two type of bounties, one for writing the templates and one for validation. Like someone wrote the template, and then we will also give bonuses on if you go and validate that, whether it's actually a good template or not. Because all we want to do is shrink the timeline into merge. So yeah, it's actually been very fruitful. One of our top contributors contributed a lot, especially in the last 6 months, and get closer to the average timeline around KVs.
Okay. Yeah, it is shocking. That's great. That's all super great. If you're in the sound of my voice and you're considering a career in cybersecurity, you want to talk to this dude. I hope that you personally are helping to, shepherd in the next generation of pen testers and red teamers who are in fact humans and not LLMs. Do you have anything final that you want to throw?
Yeah,
as we switch.
Yeah, and we talked a lot about Nuclei templates, but we have
sure did.
we have around other 30 open source repositories
and other things. Yeah,
and these are tools. So if you want to play around building security tools and contributing on those, we also have if you like the angle of engineering or software engineering with security. We have a lot of open source projects where you can go and contribute in the same way as Nuclei templates.
Great. Well, thank you so much for visiting with us today in San Francisco, live across the street from RSA, Rishi from Project Discovery. It has been a pleasure. We're going to be out for about 5 minutes, and then we will come back with more of the same.